Hello dear students, welcome you all. In this lecture, I am going to discuss about the D to A converter circuit, right? You know very well that in the previous lectures, I have covered the two different methods that are used for digital to analog conversion. These methods were a resistive divider, right? This was the first one, and then the second one was a binary ladder network. These are the two methods that are commonly used for the conversion of digital signal into corresponding analog signal. But these two methods that I have discussed, these are basically the functioning unit of a D to A converter. Functioning unit means the unit where the actual conversion of D to A takes place. But in actual, we can't use either resistive divider or binary ladder directly in a circuit for the conversion. It needs additional circuitry or additional components for executing this task, right? So here you can see D to A converter complete circuit that consists of multiple sections, right? You can see here. So the first and foremost requirement for D to A conversion is a resistor circuit. You know very well what are resistors. Resistors are those logic circuits which are used for storing digital information, right? And you have gone through the different resistors, right? Different type of resistors. So here the resistor that I am using is the very simple RS flip-flop based resistor. You can see here very simple kind of resistor I am using, basic resistor I can say, that is using RS flip-flop, right? Now here we are using one flip-flop for a 1 bit. This entire circuit that is shown here in this figure is for a 4-bit, right? 4-bit D to A converter. Similarly, you can design it for 3-bit or 5-bit or any number of bits, right? So we are using one flip-flop for a 1 bit, right? You can see here. So these are the resistors, number 1, number 2, number 3 and number 4. These resistors are used to store the digital information that is coming from that is coming toward the resistive divider or binary ladder network, right? So this is the first step where we have to retain the information, store the information. So then after this information is passed to the functioning unit. But before passing this information to the functioning unit means either we are using here binary ladder, either binary ladder or resistive divider. So in these two sections, this one and this one, there is a circuit that is shown here. This is known as a level amplifier, right? I have written here level amplifier 1, 2, 3, 4. Now what is the role of level amplifier? The role of level amplifier is to maintain the voltage level of all the digital inputs exactly same. Otherwise, the output that we will get will be distorted. So this is the role of level amplifier. One input to the level amplifier is the output coming from the flip-flop, right? And the other input is a fixed voltage supply that is of 10 volt. So the level amplifier do only one task, that it maintain the voltage level of all the bits, right? You can see here this is for 2 raised to power 0, it is for 2 raised to power 1, it is 2 raised to power 2 and 2 raised to power 3. So now all the voltage levels, if it is 0 then it means 0 for, if suppose I am applying 0, 0, 0, 0, 0, 0, 0 means the potential at all these inputs, this one, this one, this one and this one, they are exactly 0, no variation. But if they are all 1, 1, 1, 1, right? Now it is our choice that what is the value, what is the voltage corresponding to 1. Suppose it is equal to plus 10 volt. So it means here all the inputs should have exactly plus 10 volt. There should be no deviation, 9.5 or 11.5 something, right? Otherwise, the output that I will get here, analog output, that will be distorted. That would not represent the digital information correctly, right? So this is the role of level amplifier, you can see here. Then after level amplifier, we will go to the binary ladder. I have discussed it in the previous lecture how it is capable of converting the given digital signal into corresponding analog signal, right? Here you can see here at the input I have used the input gates. You can see here gate number 1, gate number 2, 3, 4. I can write here 1, 2, 3, 4, 5, 6, 7, 8. So these are known as input gates. What is the role of input gates? The role of input gates is to clock all the flip-flop, right? Now these are basically AND gates. You can see here these are all AND gates, right? So we know very well the output of the AND gate Y is equal to A and B, and it is only high when both A and B are high. Then Y is equal to 1, right? So it means I will get 1 or high at the output only when both the inputs are high. Now it is very important in a flip-flop that when we are using multiple flip-flops, here we are using 4 flip-flops. So all these flip-flops should be clocked at the same time. Clocked means they should be set or reset at the exactly same time. Otherwise, the synchronization between the different flip-flop will be disturbed, and the output that we get here, that will not be exactly the same. So the basic requirement for the resistors is that they should be all clocked at the same time. I mean, the information should be entered in all registered at the same time, and it should be taken out at the same time. So this is the role of these gates. One input to all these gates is a read pulse, and you can see when the read pulse is high, if the read pulse is low in this region and in this, if this is low, then the one input to all the AND gates is low. In that case, it is immaterial whether what is appearing here, it is 0 or 1, it doesn't mean, right? Whatever digit is appearing at the input, it is immaterial, because one of the input is 0, so the output will always be equal to 0. It means in that situation, the flip-flops will not change their state. Whatever state was present on them, right? Q is either high or low. Whatever will be there, it will be there. It won't be changed, right? But it will be changed only when this read pulse is high. You can see when the read pulse is high means 1. Now when it is 1, now the output depend upon the second input. If the second input is low, output is low, right? If the second input is high, then the output is high. And if output is high, the flip-flop will be set or reset according to its previous configuration or previous condition. So this is very, very important in this, that all the registers should be clocked at the same time. Once again, I am repeating, clock means data should be entered at the same time and it should be taken out at the same time. And in this particular case, it is entered when the read pulse is high, right? And it is taken out when the read pulse is low, right? So this is the working of a 4-bit D to A converter circuit. Different components has been used, right? Starting from the input gates, then resistor, we also call it as shift resistor, then we have level amplifiers, then we have a binary ladder, right? We are using only 4 bits here. You can see 1, 2, 3 and 4, right? But they are taking as the complement of them, right? 2 0 not whatever. If 2 0 bit, 2 power 0 bit means this is the LSB bit. If LSB bit is suppose 0, then it will be 1. So this is used for applying input to the flip-flop, right? Otherwise, don't bother that we require 8 digital input. We only require 4 digital inputs. The other input here, that if here is I am saying that if here is 0, it will be 1. So how I will attain 1 or how I will get 1? Simply by passing this input through a NOT gate, right? Because it is the inversion of this. Similarly, it is the inversion of this, it is the inversion of this, right? So it can be achieved by using a NOT gate, right? So we require 4 digital inputs, right? 8 AND gates, 4 RS simple flip-flops, 4 level amplifiers and a 4-bit ladder network. Then after whatever input we will apply, we will get output analog voltage according to it, and the formula is B0 2 raised to power 0 plus B1 to raised to power 1 plus B2 to raised to power 2 plus so on divided by 2 raised to power n, right? This is the formula, right, that I have derived in the previous lecture, but this was basically for this functional unit, and actually the conversion is taking place in the functional unit, right? But we need additional circuit, right, in order to use this binary ladder in any digital machine, right? So this is the working of this 4-bit D2A converter circuit. So sometime examiner can ask you that you explain the working of D2A converters. So if he is asking in that way, then first of all you have to discuss the D2A converters, right? Means two functional units, two types, right? So first of all you have to discuss the two functional units, I mean resistive divider and then binary ladder, and then after you have to discuss this entire circuit where actual conversion from D2A takes place. I mean this complete circuit that is used in actual practice in all digital machines for the conversion, right? So thank you very much.